All right. Let's take our synthetic division up to doing something even more awesome. All right. What happens if you keep repeating the same process? So we know that if you divide by, say, x plus 2, that's the same as x minus 2, that's the same as evaluating at 2, right? What happens if you keep dividing by x plus 2? Just keep repeating. What happens? What do you get? Well, let's do that. So we've got 1, minus 9, 27, and minus 22 for our polynomial up there. And we've got 2 here. So we do this. 1, 2, minus 7, minus 14, 13, 26, and so that's a minus 4. So if I were to evaluate this thing, it would tell me that it's x plus 2 times what is it, x squared minus 7x plus 13 minus 4. Oops. Watch those signs. Okay, x minus 2. Plug in 2, you get 0, right? So minus 4. Hopefully I've done that right. Let's do 1, 2, minus, I mean, it's pretty easy to check, right? No, plus 4. Signs. Okay. Now we do it again. We don't deal with that plus 4. That's done. That's the remainder, right? But now we do 1, 2, minus 5, minus 10, 3. All right, so we've got x minus 2, x minus 5, plus 3. So this whole thing is what's inside of that, right? And so what do we actually have? So put those two things together. We've got x minus 2 squared times x minus 5 plus 3 times x minus 2 plus 4. And now we could do it one more time. 1, 2, minus 3. All right, and so this is basically saying now we've got this thing can be written as basically x minus 2 times 1, of course, minus 3, right? Well, that pretty much makes sense. Don't really need to do that last step, but whatever. And so we've got basically here's what it looks like. X minus 2 cubed minus 3 x minus 2 squared plus 3 x minus 2 plus 4. What I've done is I've now sort of written the polynomial as if it was kind of like based at x equals 2. Like that's the new origin. So if, oh, here, let me show you. So here is so what's our original? This is our original polynomial, x cubed minus 9x squared plus 27x minus 22. So that's what that polynomial looks like. Now, if I were to graph what I just computed, well, here, let me keep my sanity. Let me graph using those coefficients. Oops, shoot. Plus 3x plus 4. All right. Look at how the red polynomial looks like it's a shifted over version of the green. It's just gone over 2 units. y2, x plus 2y is y. And in fact, we can now do g of x plus 2. Just plug in that plus 2. Oops, minus 2. Oh my goodness, the minus signs. We were dividing by x minus 2. Plug that in, and look. Now we've got, right, same polynomial, but written in a different way and sort of with a different idea. Now, this may not be that impressive with that value, although it does have its uses. For example, when I look at the polynomial, not only do I know that there's this, what the value is at 2, there's a 4, but then there's also this kind of linear term. And so that tells me that it's, as it changes away from 2, it's going to look kind of like a line with slope 3. It's kind of edging on calculus ideas. But that's essentially what it does, because around x equals 2, these are very, very small. It's very small near 2. Near 2. And so this term dominates. So if I wanted to just draw something kind of nice, I could do that. Right? And of course, I don't actually need to compute the rest of those. That was just the second layer here where I could get that sort of linear term. Right? So, yeah. Now, let me show you. So if you look on the GeoGebra thing, right, it looks like a nice little x cubed curve that's been shifted and moved. Well, let's just say that I happen to know the person who came up with this cubic polynomial, and I understand what the shift is, but I want to show you how to get it, right? Let's just say I know that. So I'm going to just try 3. Okay, and looking at the graph, it looks like 3 might be where the thing is, where the flat line is. And again, I just do my polynomial division, synthetic division, I mean. Set up 1, 3 minus 6 minus 18, 11, 33 minus 11. Did I do that right? Let's see, 1 minus 9, 27 minus 22, 1, 3 minus 6 minus 18. Nope. Did not sound right to me. 9. 27 minus 5. I still make arithmetic mistakes. So double check. It's easy to look at these computations and double check, so take the moment to do so. 3. 1, 3 minus 3 minus 9, 0. Well, that's nice. And then we do that one more time. Then we get 1, 3, 0. That's pretty sweet. So what does it tell me? Well, so this is the constant. This is the term for x minus 3. This is the one for x minus 3 squared. And then this is the one for x minus 3 cubed. And so all told, this tells me that my polynomial is x minus 3 cubed. Wait. Oh, goodness gracious. Plus 5. Signs. Anyway, x minus 3 cubed plus 5, right? So we have used synthetic division to come up with a nice compact form. Now, how did I know it was 3? Well, I mean, for one thing, I can look at the graph and see where it's flat, try things. I created this, so I kind of knew the value, but you can also play around with it. But, you know, that's just, I don't know. I think it's neat. That's really neat. So apply synthetic division repeatedly to actually write the polynomial, kind of root it at a new place. And so that's kind of nice.